This is lesson 4-6, Congruence in Right Triangles. Now this beginning part's not in your notes, but I just wanted to explain how side-side angle is not a way to prove two triangles are congruent. So if you have two sides, so if you look in these triangles, this side's 4, BC is 4, PR is 5, and AC is 5. So they're two sides that are congruent, and then you have angle P and angle A congruent, so you have an angle. But if you look at them, they noticeably are not congruent. So side-side angle is not a way to prove two triangles are congruent unless it's a right triangle, and then we call it hypotenuse leg. So that's what we're going to do today. So as I said in the diagram below, the two sides and a non-included angle of one triangle are congruent to two sides and the non-included angle of another triangle. And you can see these triangles are not congruent. Side-side angle is not a valid method. But let's look at a right triangle, how it actually works. So here we have a right triangle. Right triangle has a right angle in it. The hypotenuse of the triangle is the side opposite the right angle. Okay, so the hypotenuse is the side opposite the right angle. And we can label our hypotenuse. So if you locate the right angle, across from it is my hypotenuse. And then we have the legs of the right triangle. The legs are the other two sides. So here we have a leg and here we have a leg. So those are the parts of a right triangle. The hypotenuse leg theorem, which we can abbreviate HL, says that if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So if you need to pause the video and write that down, please do. But if the hypotenuse and the leg of one right triangle, so here's a right triangle, I have a hypotenuse and a leg, it doesn't matter which leg, but if they're congruent to the hypotenuse and leg of another right triangle, then those triangles are congruent to each other. So if we have triangle PQR and triangle XYZ and they're right triangles, they have to be right triangles, and if I have PR congruent to XZ, that would be the hypotenuse, and I have one of the legs, PQ congruent to XY, then those triangles are congruent, and the reason is hypotenuse leg. Okay, so that's my hypotenuse leg theorem. We're going to list the conditions that we need for the hypotenuse leg theorem. There's three things. First off, we have to have right triangles, so in the proof you're going to have to list that as one of the steps. So there are two right triangles. That's the first thing. Second thing, the triangles have congruent hypotenuses. So the hypotenuses of those two triangles have to be congruent. And the last thing, there's one pair of congruent legs. It doesn't matter which one, but there's one pair of congruent legs. Okay, so those are the three conditions that I need for the hypotenuse leg theorem. Two right triangles. The triangles have to have congruent hypotenuses. And then there's going to be one pair of congruent legs. So it's a hypotenuse and a leg, and that only works for right triangles, of course. Just so you can see how a hypotenuse leg theorem works in a flow proof. Okay, so given that BE bisects AD, so if it's bisecting AD, it's cutting AD in half, and AB is perpendicular to BC, DE is perpendicular to EC, and AB is congruent to DE. So I have my congruent legs, AB and DE marked, and I have my right angles marked because those were perpendicular. So let's look at the flow proof. So here I have all my given. BE bisects AD, that was a given. AB is perpendicular to BC, and DE is perpendicular to EC, that was a given too. Now let's follow this bisector. If it bisects AD, it's cutting AD in half, so AC is congruent to CD, and the reason is definition of bisector. Okay, this is a bisector of a segment, not bisector of an angle. And then I have my perpendicular lines. Now you guys know perpendicular lines form right angles, so I would say that angle ABC and angle DEC are right angles, and that's the definition of perpendicular lines. Now in most proofs I then go on to say the right angles are congruent. I don't need them to be congruent here. All I need is to say that it's a right triangle. So since they have right angles, they'll be right triangles. So triangle ABC and triangle DEC are right angles. And the reason is definition of right triangle. If a triangle has a right angle, then it's a right triangle. And then I have my other given, which was AB congruent to DE. So AB is congruent to DE. So I have right triangles. I have the hypotenuse right here, AC congruent to DC, and then I have my legs, which were given. Therefore, triangle ABC is congruent to triangle DEF by hypotenuse leg. Okay, so that's another way to prove triangles are congruent. They have to be right triangles, and you need the hypotenuse and you need the leg. So basically, you do have side-side angle, but we don't call it that because as you saw in the beginning, side-side angle does not work, but in a right triangle, it will work. Okay, so but we call it hypotenuse leg. And that's it for today.